Sunflower is an important crop choice for farmers all over the world. The first Europeans observed sunflower cultivated in many places, from southern Canada to Mexico. This exotic North American plant was taken to Europe by Spanish explorers sometime around 1500. The plant became widespread throughout present-day Western Europe, mainly as an ornamental, but some medicinal uses were developed. Sunflower became very popular as a cultivated plant in the 18th century. By 1716, an English patent was granted for extracting oil from sunflower seed, and by 1769, literature mentioned sunflower cultivated by oil production. By 1830, the manufacture of sunflower oil was done on a commercial scale. End use of sunflower seeds includes human consumption, industrial demand, for example crushing, and the feed industry. Today's European market for sunflower seeds is highly dynamic. The largest suppliers can be found in the Black Sea region. DuPont Pioneer has a strong position on the sunflower seeds market in Europe. Pioneer brand sunflower hybrids are developed by combining our global innovation capabilities with local testing and service, enabling growers to plant the right hybrid on the right hectare. Pioneer began sunflower research in 1983 with its first research station in Argentina. Within a year, we expanded sunflower breeding into Minnesota and California. The focus in Woodland, California, was to acquire germplasm and to support research networks for the Australia and Europe markets. In 1987, the first Pioneer brand sunflower hybrid was sold in the U.S. From 1987, the breeding program of sunflower expanded in Europe, starting from Spain. Today, Pioneer has 13 research centers for sunflower and sells seed in North America and Europe markets. Pioneer is the only company with balanced breeding efforts across the Mediterranean, Spain and Turkey, Black Sea, Romania, and continental sites, France and Hungary, covering all possible genotype discrimination effects of the European sunflower growing environments. On top of this, the testing network also covers Russia, Ukraine, Serbia, Italy, Austria, and Bulgaria. In 2016, Pioneer officially opens a state-of-the-art sunflower technology center in Seville, Spain. The advanced technological capabilities of the center will allow Pioneer to double the rate of yield gain and expand the Pioneer Protector defensive trait lineup. Technologies already operational at the center include accelerated forward breeding, AFB, accelerated trait integration, ATI, utilizing embryo rescue, and high-throughput broom rape and fungal disease phenotyping.
We are in the new Multicrop Technology Center of Pioneer. We are located in Seville. We choose this environment for building this technology center because it's the environment with the highest accumulated sun radiation per year in Europe. This is a crucial factor for us to decide conduct a multi-crop center in which we are going to conduct all year round crops in greenhouse structure. This is probably, even when this center is a multi-crop center and we work on canola, corn and sunflower, in the first stage in the first phase of this center, we are dedicating most of our effort to sunflower. Here we have the largest sunflower greenhouse area dedicated to sunflower research in the world, with 1 hectare of gothic roof greenhouses in which we are applying cutting-edge technology for drip irrigation, cooling, heating, and photoperiod extension. Plant breeding starts with line development or trait integration. This is a process that takes several crop cycles or generations. This process, if it is conducted only during the growing season in the year, can be conducted over 1 generation or 1 cycle per year. If we use winter nurseries, this process can be conducted over 2 cycles per year. In a technology center like this, using greenhouse crop conditions, extension of photoperiod, artificial extension of photoperiod, and the embryo rescue, we can conduct up to 4 or even more cycles per year. The process starts at this moment, in the moment of the embryo rescue, in the greenhouse. The duration of the green filling is approximately in sunflower 35 days. With our technology, after 10-15 days after fecundation, we are able to rescue the immature embryo and grow in this immature embryo in a media. This is the first lab. We call it the dirty lab. And here is where we receive the heads that we harvest in the greenhouse. And the sterilization is done here, the first sterilization of the heads. So we have the sunflower heads prepared for embryo rescue. Once they are sterilized, they are moved to the other lab, to the embryo rescue lab. This is the lab where we conduct the heart of our activity in this technology center, which is the sunflower embryo rescue. Approximately 10 to 12 days after pollination or after fecundation, we harvest the heads, and these heads are sterilized in the first lab. They come sterilized to the second lab, where the embryo rescue process is conducted. So to conduct this process in this table, we prepare the embryo culture media that is put on this type of phytotrays, and then the embryo, the culture process itself is conducted in laminar flows, as we can see in the lab that is happening now. Once the embryos are put on the embryo culture media under complete sterilized conditions in this cutting-edge lab, they are grown in the growth chamber during approximately 1 week. This is the growth chamber where embryos grow approximately during 1 week from the moment of the embryo rescue, like this, until the moment in which the embryos are ready for transplanting. In this camera, all environmental variables are controlled. The light, temperature, humidity, absolutely everything. After 1 week of growth in the growth chamber, the embryos, now plantless or seedlings, are separated from the culture media on these tables and put in water before transplanting to the small pots. After the embryo rescue process and the embryo growth, the seedlings from embryos are transplanted to small pots. These small pots are put on these type of tables, in which the plants are hardening during approximately 1 week, and after that week, the plants are ready for leaf punching. Leaf punching to obtain tissue samples for molecular marker analysis. Molecular marker analysis takes approximately 1 week and help us to select the plants that are carrying the right gene combinations in the both accelerated forward breeding or accelerated trait integration processes. After 1 more week, the plants are ready for transplanting to big pots. The plants selected on the tables using molecular markers and then transplanted to these big pots in the greenhouse. These plants are grown until flowering under these greenhouse conditions with artificial extension of the photoperiod. And then at flowering time, depending on the process in which these plants are involved, they are emasculated and crossed, or they are self-pollinated. After 10 days to 12 days after the pollination, the embryo rescue process starts again. Although the main focus of this center by the moment is sunflower, we are also calibrating the embryo rescue activities and greenhouse crop conduction in a crop like corn, which is the main crop of the company worldwide. Precise phenotyping in sunflower means artificial inoculation of fungal diseases and parasitic plants. In this technology center, we have a pathology lab in which we have calibrated methods of artificial inoculation of broom rape, Phomopsis, verticillium, rust, and downy mildew. In the case of broom rape, for example, which is what we are seeing here, we have different races coming from different origins that we use to inoculate under different inoculation systems, mapping populations or commercial or pre-commercial materials to characterize them.
Everything we saw in this video combined with likely the largest local testing in Europe and a broad network of qualified technical sales specialists across Europe, uniquely positions Pioneer to provide growers with the hybrids and technologies most adapted to their local needs.